Welcome to your last talk for today with Suman Shah, and he is talking about his project Stegosploit.
Thanks. Good evening, and thanks again for having me at DeepSec. It's glad to be back here, and the weather was actually much better than all the past DeepSecs that I've been so far. I've only been able to step out at night during DeepSec because the weather is pretty awful, but today I took a special round and indulged in some photography. So I'll be talking about the internals of Stegosploit. This stuff has been released last year. I first released it at Hack in the Box, 2015, and then have been talking about it quite often. And several times it's been mistaken for being something like the most evil virus around or whatever. It is not that. This talk is to illustrate what Stegosploit is, talk you through what I've been doing in the past 4 years, building up upon exploit delivery concepts. And the culmination of my work is this exploit toolkit. So with this, let me get begun. I've done a lot of offensive work in the past, exploit writing, browser exploits. These days I've been doing ARM exploitation and such. But there's two things I've seen when it comes to exploits and the success of exploits. One, if you have a 0 day, well, and then you own the internet and you can do whatever the NSA does. The second, if for guys like me who don't have O days, your best bet is to succeed in exploit delivery. So as I say, a good exploit is one that is delivered in style. There's freshness of an exploit, and there's delivery of an exploit. Stegosploit is all about exploit delivery. There's no 0 day here. These are not like evil images that will blow up your browser and all that. Stegosploit is an exploit delivery technique. We're going to take existing browser exploits, encode them on images as pixels, and deliver them as pure images to the target browser in such a way that they automatically get decoded and exploit the browser. So instead of just sending JavaScript, we'll be sending pretty pictures to exploit a browser. That's the end result of the whole thing. So I'll be talking about design goals, what led me to design, what are some of the design principles of Stegosploit, what was the motivation and all that. How do we take a regular exploit and turn it into an image? I will also talk about steganography techniques, and I'll talk about polyglot techniques. And then I'll talk about, what the heck, man? Okay. Nope. My phone was like buzzing like crazy. Never mind. It was a DLC. Right. Then I'll talk about steganography techniques. I'll talk about the decoder process. I'll talk about polyglots, and then we'll, discuss what needs to be discussed. Design goals. What was the motivation? I have studied a lot into image file formats. And one of the things that came to light is, okay, here's an image file. Here's a JPEG file. I enjoy photography very much. And I've dug into images for watermarking and for secretly putting my name in places so that I can catch plagiarists and all that and modifying pixels. And that kind of led me down a path where I was dealing a lot with file format internals. And then I thought, okay, can we not use this to put a browser exploit on there? So that was the whole motivation behind the talk. So one of the goals was I only want to have valid images flying across the network and disk. Somebody should not see anything but a well-formed image. The exploit code itself is hidden as pixels in the image. It is not as an ASCII string. The goal is we do not want to get detected, we do not want to get signatured, and we want to look pretty. The decoder for decoding these pixels and attacking the browser is also contained as a part of the image itself. when the image is loaded, under certain conditions, of course, when the image is loaded in a browser, directly, like through the URL, this image will automatically decode itself. The JavaScript decoder will run. At that time, the image is not really an image. It is a valid HTML file. It will run, it will decode itself and trigger the exploit. So all this is done using just one image in style. So before we go ahead, two concepts that we need to clarify: steganography and polyglots. What is steganography? It is the art of camouflage. You disguise an attack string, an offensive string, into something that is perceived as innocent, so that at first look you never notice what's in there. Now, steganography has been around for years, and there's been a lot of advanced stego stuff that's been talked about. My steganography is pathetic. It is very primitive. It is like ridiculous, but it works. And that's the goal. Also was to keep the steganography very simple, so that I don't have to do too much effort in decoding it. Now, the other important thing: what are polyglots? Now, polyglots are fantastic things. Ange Albertini, he is the polyglot master, and he talked about polyglots a few years ago, and also wrote up about polyglots in the International Journal of POC or GTFO. So polyglots are basically two or more data formats that reside in a single container, such that they're both valid at the same time. They do not break each other. One of the earliest examples of a polyglot was a GIFR file. It's a GIF file and a Java archive at the same time. Now, the way you can do it is you just simply concatenate the Java archive at the end of the GIF file. So if you read the file from top to bottom, it is a GIF file. But if it is a Java archive, it's a zip. So if you try to extract it, all zip files extract from the bottom to the top. And that was a polyglot. But here we got a lot more complex polyglots. And I'll talk to you about what polyglots are. So now, how do we use these techniques to exploit a browser? Like supposing you just have regular exploit code, and then you want to deliver it to the browser. You can deliver it using ugly JavaScript, and then you get caught by all the FireEyes and the Silences and whoever, you know. We don't want to do that. We definitely want to make life difficult for them. So you take an image, you combine these two, take the exploit code string, bit by bit, and encode these bits as pixels onto the image. So then you get an encoded image. Now we can't simply deliver this encoded image to the browser. We have to have something that decodes the image at the browser layer. So we come up with a JavaScript, because that's what runs on browsers, to decode your image. You can deliver these two separately, but that's not style. So you got to combine them into a polyglot, into something that is an image and JavaScript at the same time, and then throw this at the browser. And the browser doesn't know what to do. And then we'll trick it to do what we want to do. So let me show you the sequence. I have some demos. First, we'll talk about how to hide exploit code in images, the basic concepts of steganography. It's very simple, and this will take you a little bit into image theory. Images are basically made out of colors and pixels. You have a grid of pixels, and each pixel has colors, three channels of colors, red, green, and blue, and each channel can have 0 to 255 different values. We will talk about black and white images because they're a little simpler to encode. The same theory works on color as well. But think about it like this. You have an image built up one pixel after the other. This was, by the way, done at my house. We do a sand painting on Diwali day with literally sprinkling sand on the ground. And that, I thought, is the closest analogy to pixels in real life. So you take an offensive string. Like here's an offensive string. You split it into a bit stream and encode every bit as a pixel on this image. Now, of course, this is exaggerated, but if you just throw the pixels, very tiny pixels, you'll never see the difference. But the encoding is there. So now, what we can do is take an image like this, take this exploit script. This is CV 2014-0282. It's a use after free exploit, all written in JavaScript. This is the JavaScript with the ROP chain and shell code and everything in there. And this gets encoded bit by bit onto pixels in this image. So in the result, here is your encoded version. Can you see the difference? Of course you can. Right. No, I mean, if you can, you like got Superman vision. But you can't. So now let's talk about how it's done. I want you to think about an image as 8 different layers. Think about it as papers, 8 papers stacked on top of each other. Transparent papers, transparencies. Each layer corresponds to a bit. Now, if you talk about grayscale images, you have 255 different shades of gray, which can be represented in 8 different bits. So if you take an image and split up the bit layers, you get something like this. You have 8 layers. The topmost layer is the most significant bit, and the bottommost layer is the least significant bit. And if you stack these layers on top, you get the resultant image. What we're going to do is we're going to write our offensive stuff onto one of these layers and simply pack them together. It's a lot of bit shifting, but it's very simple stuff. So we can choose which layer. These are the 8 different layers shown alongside. The most significant bit contributes most to the shape and form, and the least significant bit contributes most to the detail. Now we can hide our string in any of these 8 layers. We will see how to do it. I'll give you a demo. Right. So to give you an illustration, if this is the image, we start with the least significant bit, bit layer 0, and start stacking each layer on top of the other. And when we finish stacking all of them, you get the same resultant image. Right. Let me do a quick demo about images and encoding. I'm going to have to try to do it one-handed. Okay, just mute me, please. Okay, so here let me take the image. Load it. And here's the image. I'm going to show you how the encoding is done. And before the encoding, I will show you how the different layers are as well. Okay, so this is the source image. If we step down each layer, now here on the, I am laterally challenged, so this side of the Basically, this side of the screen, I have a laser pointer. Why am I even forgetting that? This side of the screen shows you the bit layer, and that side of the screen shows you the image itself. If I step down the bit layers, this is bit layer 7, this is 6, 5, 4, 3, 2, 1, and this is the least significant bit. And if I start stacking all of them up, then you can see that the image basically composites itself. And here, yeah, we get everything back. So what we'll do is we will take one of these layers and write our exploit code on it. We will initially do it on layer 7, that is the most significant bit. There's some other parameters. The grid parameter that you see here, this grid parameter is basically how many pixels do you want to leave in between each encoding. So we write every third pixel. And we can write our own JavaScript code, or I will take a ready-made exploit, which is something that I wrote too, and encode this JavaScript stuff onto the image. Click on process. By the way, all of these tools are in JavaScript and HTML. They work on any browser that is HTML5 compliant. These are freely available and distributed in the issue number 8 of POC or GTFO. So here when I encode it, if you look at the resultant image, this image, you can see, if I zoom in or close up, you can see the aberration in the image. Here you can see the pixels and you can clearly make out something is really fishy. This is no good. So we got to go down the layers, and if we start writing deeper into the layers, we'll be able to hide very well so that there is no visual aberration. So if I go down to layer 2, for example, and process this, here of course on this side I'm showing you how the pixels look. This is an exaggerated view. I'm deliberately coloring them. But the resultant image, you can't see anything. The image, the difference is so minute that our eyes will never be able to pick it up. So now we got to take this and we got to now encode this on a real JPEG file. There are challenges when encoding on JPEG. I still consider JPEG as a pure image format because that's what it's come out of the photography origins. But JPEG is lossy. JPEG employs lossy compression. So some pixels get approximated, and if we do this for steganography, our message might be lost. So I was actually breaking my head over this for a long time, for several years. And at Hackaloo 2014, I had 3 extra days that I spent in the hackerspace over there. I came up with the solution of iterative encoding, which is what I'll show you. I basically gave you a demo of this already. So let me show you how to encode on JPEG so that it is resistant to lossy encoding. We will now encode the same exploit string onto the pixels. Iterative encoder, that's it. Load the image and choose the bit layer, which will be 2. I will choose the grid as 3. If this was color, I can also choose the channel, but it's not, so I'll just say all. I'll choose the exploit code, and then I'll click on process. So here is the first cut, but when we try to save this, some of the pixels will be dropped. So the way I got around the lossy encoding was, at first I tried to attack the Fourier transformations and the DCT tables and all that and see if I can hide in there. F5 steganography does that. But that becomes too complex, and that math was beyond me. I couldn't understand all that crap. So I said, let's take the donkey way out of this. If you encode something, maybe 50% of the pixels fall off, but 50% of the pixels stick there. So now you take what's sticking there and re-encode on top of what's sticking. So take the resultant image and pass it through the encoder again, and again, and again. Iterate until all the pixels stabilize. And in a few passes, you'll get it done. So I'm going to turn on the slow motion flag over here and show you the iterative process. Here you'll see the resultant image, and here you will see each version, and the error pixels are shown in red. And you'll see that the errors decrease until the image actually stabilizes. So here you go. Pass 1, pass 2, pass 3, 4, 5, and the percentage keeps going down and down until we get a stable image. Now all the pixels have stuck. There are a few errors, but they do not bother with the decoding. And here you get a clean decode. The same thing gets decoded back, and the exploit code is now stuck as pure pixels. Okay, so far so good. We got that out of the way. Encoding is done. Now comes the challenge as to how the hell are we going to decode it. And this decoding has to be done in the victim's browser. So we can only use what is available to a browser, namely JavaScript. Fortunately for us, JavaScript in HTML5 has this beautiful element called canvas. And canvas lets you draw images and manipulate existing images using just JavaScript. So all we're going to do is load up an image, turn it into a canvas, read the pixels one by one, figure out where we've encoded. We know which pixel contains the encoding, lift the bit stream out, reassemble the bit stream, and then trigger the exploit. So the decoding is very innocent. Even if you analyze the JavaScript for any maliciousness, all it is doing is running a loop and building an array and doing bit shift operations. There's nothing malicious in there. Even semantic engines or AI engines cannot detect anything malicious. Here is the JavaScript code. It is like 200 and something characters, really compact. If you want to obfuscate this JavaScript code, you can turn it into a JJ encode, which uses only symbols, no alphabets, no numbers. But now, we're going to turn this into, let me show you how to decode it. Oh wait, also let me show you, let me show you how to decode this stuff. Image decoder. So here it is. So you give the name of the encoded image. The bit layer that we encoded it as, bit layer 2. The encoding channel is all, and the grid is 3. So here's the image, and if I click on decode, the image will be decoded, and this JavaScript will be reassembled from it. The decoder script is what I showed you in the slide. Now the question is, if you want to deliver this, you have to deliver the JavaScript for decoding and this image separately. That's no good. We want to do everything in one image because we made the assumption only valid images on the network and disk. So now it's time to turn to polyglots to help us. Like, can we simply create one file which is JavaScript at the same time and a valid image at the same time. And this will give us images that auto-run. So here's my whole trick called images, which is basically an image and a JavaScript polyglots. So the same file, if you load it in an image tag, it will draw pixels. But if you load it in the DOM or you load it in the script tag, it will execute the JavaScript that is polyglotted inside it. Now, we step back a little. How do polyglots work, and how do these weird and evil things work? I came across this incredible concept reading an architecture blog, and somebody had written an article where they described the concept of Nakatomi space. This kind of resonated with me very well. So if you watch Die Hard 1, Bruce Willis, he traverses the entire Nakatomi Tower through all ways which are not intended to be used. He's going up and down and across the tower through air ducts and vents and floors and ceilings and elevator shafts, not by using regular doors and windows and stairs. If you think of any complex network or a complex software or complex architecture or a file format, there will be a lot of Nakatomi space in your entire organization or your project or your file format. And it is this Nakatomi space that we want to use to sneak in our stuff. So let us turn and use this concept for creating a JPEG plus HTML plus JavaScript plus CSS polyglot all in one file. We got to attack the file format. So we have, hey, how much time do I have? Oh, great. I thought like you're going to say 5 minutes and 20 minutes. Now you're going to say 15 minutes. No, joking. All right. So we go through the file format of the JPEG structure. Every JPEG image begins with a SOI marker, which is called a start of image, and all your JPEG markers are FF with some other code number. So it always FFD8, and the next marker is app0, which basically says this is a JPEG file and JPEG major and minor version and gives you the X and Y resolution. And that is FFE0, then you have a 2-byte length, then you have the characters JFIF, null byte, 2-byte version, and blah, blah, blah. And then you have your quantization tables, which is basically your compression and decompression tables. And then you have your start of the frame. And then you have the compressed pixel arrays in here. This basically is your JPEG structure. What we're going to do is we're going to create some extra space for us by tweaking the length parameter. If you simply increase the length, you get a whole lot of extra space beyond this much. And in this Nakatomi space, you squeeze in actual HTML and JavaScript. You can like create fake attributes, and you can create like whole lot of random obfuscated stuff, but you sneak it in right here. This will not, and then you pack your rest of your DQTs and Huffman tables and everything after this. This will not interfere with the JPEG format, and no decoder has ever complained. I've tested this on pretty much everything, and it works. If you load it in an image viewer, it will load as a valid image. If you load this directly in the DOM, then the HTML tag will be parsed first, and this will run as an HTML document. This is the insanely awesome thing about polyglots. You can do the same stuff with PNG as well. PNG uses a much easier format called 4CC, which stands for 4-character codes. Everything begins with a 2-byte length, a 4-character code as to what the section is, and then the data and the CRC. And you can create an illegal 4CC or even a legal 4CC, which is a text code, and simply put in text in there, anywhere in your document. And then put the correct CRC there. And then you have the rest of the PNG data. So with images like JPEG and PNG, these are the most popular images used. We can create our Nakatomi space, squeeze in the polyglots, and then do what we need to. Time for a demo. Okay. I hope this thing works. It's always the most nervous part of the entire presentation. Mute the Okay. So first, let me show you that there is an image which we've generated with the encoded pixels. There is also some template files. So here is the HTML template which we will squeeze into the JPEG file. So what I'm doing is I have an HTML tag, then I have this marker called random. This will be replaced with just complete random garbage, because HTML will simply ignore anything, any unknown attributes in there. And then I just create all these tags full of random attribute crap, so that you kind of space it around. And then here I have the JavaScript, which is going to be the decoder script. Now, if you load this as an HTML, inside the JPEG, there'll be some JPEG nonsense that will be shown on the top of the HTML page. So here you use some style sheet tricks. You basically make the entire body hidden, and you only turn one portion of the DOM as visible. What are we going to turn as visible? This image part. If you see this image tag is a special tag. You see image source equals hash, which means load my own self. So this HTML file is loading itself back as an image, and it's going to work because it's really a JPEG file. So that is where we're going to see the pixels come out. And then at the end, I have just a script with an illegal language, so the rest of the JPEG will be effectively commented out, and it will not bother with JavaScript execution. So this stuff I had to do to make sure that the JavaScript and the JPEG play nice and they don't interfere with one another. The decoder script is, here's the decoder script as I showed you, and now we're going to convert the we're basically going to convert the turn the image into a polyglot. So here's the script for turning the image into a polyglot. I've already done this, but let me try and do it again. Give the arguments, okay, I have output.jpg. So this generates the HTML template and JavaScript. If I open output.jpg, just like this, it'll open up in the image preview absolutely normally. If you do a get info, even if I look at the EXIF properties, it'll all be perfect and proper EXIF properties. I don't have any in here, but it'll show you if you have like a Nikon camera or whatever, it'll show you everything without disturbing it. So for all practical purposes, this is a valid image. But if we look into the image, now here you'll start seeing the weirdness. So here you have the start of the image marker. Now you have this funny little HTML thing. But it's HTML, and everything from B9 onwards is a large illegal HTML attribute. This will not get signatured. It's random enough. But if you go down a little bit, you'll start seeing maybe some fragments, which I still cannot avoid. I'm going to try and work around those somehow. Here you have this JavaScript over here. This is the only part which looks a little weird. We can, instead of doing this, we can obfuscate it. And instead of using compact, you use JJ encode. And now if I look at the output, I still have the HTML stuff. My JavaScript has now basically turned into, where is it gone? Yeah. Terminal nonsense. See, all the EXIF data is there intact. Here is the JavaScript. This is the offensive JavaScript, which is absolutely no symbols. I mean, no letters, no numbers. And this is the decoder script. So we can take this and now hit it against the browser. So let me do that. I've talked about all this quite enough. Time to put this into action. Currently I've programmed this so that it triggers on click, but you can also trigger it on load. The reason why I triggered it on click is because I need time to talk you through it. I'm going to load this. And here I have, so I've embedded a interpreter payload in there. So hopefully if this works, we'll get a shell and then it'll shovel mimikatz, it'll shovel a privilege escalation exploit, and do all the fun stuff. Keep an eye on the performance counters. And if I can find that polyglot. There I have this one. Now this is the one I'm using. It's basically, I've taken the file and I've removed the extension from it. So now the browser has to guess what type of content it is. And by forcing it to guess, it will mistakenly guess it as HTML because it finds the HTML marker in the top line. And somehow in Internet Explorer land, it takes more priority than the JPEG marker. When you load this, you will actually see the image without any hitch, without any problem. Because I have the image tag in there, the image source equals self, that is pulling the same file back up. And there's no other network traffic going on. If I click on the image, it will start a heap spray. And because heap sprays in IE are pretty slow, here you can see the CPU spike to 100%. We keep an eye on this. And hopefully, if everything goes well, it doesn't make me look like a fool. And we will see shell pop out. There it goes. There's a back connection. There's a interpreter. It's dumping. It's like dumping the process, mimicatzing it. It uploaded a privilege escalation. At that time, the browser crashed. But browsers crash all the time, so people just don't even care. It even took a screenshot and placed it on the victim's desktop, saying, here's a screenshot. It placed a Stegos file saying, hi, you're owned. And yeah, and if we actually get into a shell, and we have a shell. Who am I? I am system. God mode. All this using one image. Thank you very much. So ladies and gentlemen, that is Stegosploit. It is known exploits doing everything over one image. I don't think I have time to give you a PNG demo, but it works too. It works. 5 minutes left, excellent. And then we have Q&A, right, after 5 minutes. All right. So I have only a few little bit of concluding stuff to do. Talk to you about PNG. So conclusion, detection, nothing detects it. It's all clear. This technique isn't new. And I mean, I'm the only guy talking about it on stage. I've been talking about it since a very long time. But my initial research was on something called 255 Shades of Grey, which I also presented at DeepSec 2012. But that got turned into an actual malware, and they were using the same code as I presented. And somebody tweeted saying that protocol spanning, syntax-based generalized exploit methodologies are the new black. I mean, this is the way of the future in terms of attacks. And the reason why they succeed is because the defense is reactive. We always react to new attacks, and people say, okay, so how can we fix Stegosploit? I said, I don't know, maybe, but that's the wrong question to ask, because if you look at InfoSec defense today, all we're doing is rules, signatures, updates. Now the new buzzword is machine learning. So at the first level, what really needs to be done is a wake-up call for browsers and the W3C. Browsers really need to take the security model quite seriously. And in doing that, don't be afraid to break the web. Sure, let shitty HTML be broken. A few guys with messenger bags and coffee drinking, chaps will cry and scream, but that's okay. They'll get over it. And the W3C is, the W3C really needs to enforce strict parsing rules like compilers. Browser compliance is the W3C's responsibility. And if a browser is not compliant, the W3C should have something like a Wi-Fi alliance thing. It doesn't get the W3C stamp. Educate the users, don't use it. I mean, if you take HTML rendering today, you can have crappy HTML. You may have unclosed tags and garbage attributes, and they will render without a complaint. But if a C programmer like me writes shitty code with no semicolons and no closing braces, the compiler doesn't cut me any slack. You don't get A dot out. Sorry, go home. Do I cry? No, I don't. But if you break something like this, see a Twitter storm come out. So, well, that's the first cut. There's a lot more to talk about. I highly encourage you to play with it. The tools are available in Poker GTFO issue number 8. Poker GTFO itself is a polyglot. It's a PDF file. So if you unzip it, unzip a PDF actually, you'll get a PNG file out of it. That contains the Stegosploit toolkit. Rename it as .html, open it in a browser, it'll drop a 7z file, and that contains all the tools. Well, you got to be worthy of getting it. If you can do it, then you'll appreciate the whole concept of polyglots. And the paper is on stegosploit.info. So towards the very end, I've reached the end of the talk. Got to put on my Make Security Great Again. That's what the hat says. Thank you very much for your time and attention. Questions? Let's have at it. This is the last talk, so. Anyone? Yeah?
So thanks for your great talk. I would just like to give an annotation. I mean, I know all the stenography stuff from other side, from playing CTFs.
I beg your pardon?
I know the stenography stuff from other side, like playing CTFs to capture the flags.
Yeah.
There are a lot of fancy stuff with stenography where like stuff is hidden in images or GIFs.
Yeah.
And it's also really an interesting topic, and it's really great to see how you can own people with stenography and like no one is caring about it. And it's like you see how security is like broken because no one cares about like the HTML stuff you showed. Like if you programming stuff, it's like some little mistake and it's not working. And HTML stuff, you make some missing text and still working. It's really bad that it's like then happening and everything gets pawned because of people don't care.
Yep. You're absolutely right. My initial research was with BMP and GIF, and that's the easy stuff. The JPEG and PNG was the more complex, and that required a lot of hiding. But you're right. A lot of security issues happen because of weak adherence to standards. I mean, we can talk about it, but you want to do a trade-off between flexibility and enforcing the basic standards. You had a question. Yes.
Okay. Thanks. Have you looked at the exploitability of typical mail clients, like you're using a Mac, like Apple Mail, for example, and the HTML rendering engine there?
So exploitation of, Stegosploit on anything but a browser, like say email client. Yes, I've explored it. The good news is it doesn't work. Let me take a step back and tell you why it doesn't work. So for this thing to work, the image must be loaded as the top URL. Basically, when you're loading the image, you're not really loading an image. You're loading a data stream, which is an HTML, and it populates the DOM directly. If it is embedded, so if, like several people got this misconception, and there's one guy who called me an Indian script kiddie on Twitter and all that, because he didn't RTFM. He didn't read he wasn't even there in the talk. But if you embed it as an image tag, like let us say Facebook asks me for a profile picture. If I upload this as a Facebook profile, it's not going to work, because once it is inside an image tag, it stays as pixels. Unless you right click that picture and load it in a separate tab, then boom, you get owned. So if you're delivering it over email, it's not going to work in your email client. But if you like, say, save it and pop it open without an extension, then you get owned. Yes. Another question. There's one at the back and there's the gentleman there. Yeah.
Yes. To avoid the loss of information critical, that the exploit and the JavaScript, I think that you put redundancies, reiterating the information in JPEG.
Yeah.
How many iterations in your experience?
So that is a great question. So when we talk about iterative process, like when do the two image, when does the image stabilize? Typically for a length, the exploit length I typically take as about 1 kilobyte of JavaScript code. 1 kilobyte in an 800 by 600 pixel picture will take about 8 to 9 iterations to stabilize. You may, in some odd cases, you might get a game of life thing where, the pixels keep flipping, like one pixel keeps flipping alternately. In that case, screw it, take another image and apply it on a different image. And then it'll stabilize. The larger the image, your stabilization will be very, very quick, because you can use a wider grid. Question at the very end.
Yeah. Oh, shit.
That's all right.
Wake everybody up. So you talked about browsers being like responsible of this. I totally agree. Like the most important thing I see here is like the content sniffing thing in the browsers. Like that's one of the things that they could actually solve. Like you see this content type sniffing, no sniff thing. Which would wouldn't solve this, but it would solve the non-extension thing, right?
Yeah, it solves the non-extension thing. That's true. So if you actually had an attacker-controlled web server, like if I were serving this from my own web server, I will put a content type text HTML tag, even with a .jpeg extension, and then it will be loaded as text HTML. This is like in my paper I also talk about content sniffing and reference the work done by Michael Zalewski as to.
Yeah, exactly.
Yeah.
And whole Rosetta, all that.
Yep. Well, there's a lot of crap in the browsers. Yes.
Hi.
Hi.
So you said that browsers should be more strict about what they accept.
Yep.
So having talked to people at Google about this, they would have loved to harden Chrome as best they can, but they're afraid that once they do that and some websites break, they're going to lose their users. So what good would Chrome be if it's hardened to the full extent, but no one uses it? So I'd like to ask what you think about that.
Well, see, today, if you look at browsers, it's essentially between Chrome and Firefox on the desktop and mobile Safari on the mobile. Nobody gives a rat's ass about the other browsers. Like desktop Safari is pretty much dead, and Internet Explorer is Internet Explorer. So, I mean, I've talked to the security folks at Firefox, and it seems both of them are really, really afraid to break the web. Somebody's got to take that first step, you know, boo bloody hoop, let people cry. Like I said, they'll get over it. But that is the first step. You got to make browsers like compilers. Yeah. Yeah, I mean, they're talking about, you know, forcing HTTPS everywhere, but you know who's going to cry the most? Content delivery networks. They are going to scream and shout and suffer and wail. I don't know, there's a lot of strong arming going on, but if they do it, might as well sneak these things at the same time, saying, yeah, here you go, you know, one big change and a whole lot of other changes, deal with it. Apple does this to its users all the time. Like they call it courage, right? So if Apple can show courage and bring dongles back again from the 90s, right?
So we're coming to the last question for today.
He gets it.
This one.
Okay,
is
so
here.
both of you get it.
And
Hurry up.
Yeah, we can.
Hurry up,
have to cut
both of
it.
you get it. Race condition.
Yeah, sorry. Yeah, do you hear me? Okay, yeah. You mentioned this being pretty hard to detect,
Yeah.
and I can very well imagine that. But as somebody who's worked a bit with NIDS like Suricata and so on,
Yeah.
I could imagine doing stuff like creating a signature that triggers on HTML tags
Yeah.
inside JPEGs. So what I mean, or starting HTML tags.
I got
So,
it, and
yeah.
this has been asked to me by one of the Suricata developers as well.
Mhm.
You're going to run into a huge risk of false positives because EXIF tags from cameras sometimes contain like HTML and even XML markers. Photoshop throws a whole shitload of XML in your JPEGs. So you're going to scream about every goddamn thing.
I
So
see.
you
That's
look
really
at that, you're entering a world of pain. Last question.
Okay. Well,
Uh,
I mean, we can carry on if you're still interested. Depends on you.
You get it. Wait.
Hi.
Hi.
So just a little question about your iterative encoding. I don't know a lot about JPEG, but I think there is now a lossless version of JPEG which you can use. I was wondering whether you tried using that as a way to kind of shortcut that and get around that kind of game of life situation you were talking about.
Yeah, so your question is about lossless JPEGs. There's JPEG 2000, which is lossless. You can absolutely do that. But here's a better trick. Use PNG, which is lossless to begin with. In PNG, you can get away with one iteration every time. Whatever you put in there sticks. So PNG is lossless and it is great. JPEG 2000, I've actually not played with it. But yeah, it's worth playing with it. You're right. Right then, anything else? Or we call it a day? Yes. Oh, great.
Did you try or think about other files like video files, sound, audio files, and all that other stuff that gets loaded and played in the browser?
Yep, I did. Other file formats. The one difference between images and audio and video is that images are natively handled in the DOM, like at the browser core. They're always loaded. The audio and video files always need a plugin. They're not as native as the image tag. They will still use another library. So when I load an image, it can be loaded as the DOM itself. But if I say do this in an MPEG file, video or audio, it will not be loaded as the DOM. It'll get handed off to the player. So while yes, you can do the steganography in it, but you cannot have it decode itself. Corollary, you can always send two things. You can send the decoder script separately. We lose a little bit of style, but you can do the steganography in audio and then have a decoder script and have at it. But while I just said it, there's nothing like a canvas for audio or a canvas for video. So JavaScript won't be able to load those objects or manipulate those objects natively like the image. Yeah. Oh yeah, sure. You just submit a new standard, ECMAScript 7, just tell them to do it. My big suggestion is tell JavaScript to implement pointers. And that'll be the end of the internet. Right,
Okay.
well, I think we're going to wrap up.
Yeah. Well, one last
Oh,
question.
sure, why not? One last thing.
So basically, you encoded your exploit in one of the layers.
Yes.
So that would be possible to encode another one in another layer?
So not only that, kind of building on your stuff, you can encode your stuff on several layers at a time. If you keep the layers low enough, you can split across different layers. If you take a color image, you can split across 3 channels as well. So you kind of got a few permutations and combinations of scattering the pixels up and down layers or across channels. Can do. Can do.
Multi-browser exploit.
Yeah. All right, this is the end, absolutely.
Thank you.
Thank you for your time and attention.